Good afternoon, students. So today we see solution of some more problems on pedal equation. So in the last classes we have seen the solution of pedal equations. So today we solve some more problems on pedal equation. So here the first problem is find the pedal equation. Find the pedal equation of the curve. Find the pedal equation of the curve r raised to n is equal to a raised to n sin theta. Okay, so this is the given problem. Find the pedal equation of the curve r raised to n is equal to a raised to n sin theta. So solution. So first what we do, we find the phi, that is angle between the radius vector and the tangent, by applying the formula tan phi is equal to r into d theta by dr. Correct? Okay. So what we do, as I already told, either you can apply logarithm or you can directly differentiate. So the given equation is r raised to n is equal to sin theta. R raised to n is equal to sin theta. Okay. So now differentiating this directly. So n into r raised to n minus 1, because x raised to n differentiation, n into x raised to n minus 1, okay, into dr by d theta is equal to a raised to n constant, differentiation of sin theta is cos theta. Correct? So then which gives again this dr by d theta is equal to so actually some make a correction. R raised to n is equal to a raised to n sin n theta. Okay, so actually the problem is find the pedal equation of the curve r raised to n is equal to a raised to n sin n theta. Okay, so according to that, here we should take this one as r raised to n is equal to a raised to n sin n theta. So this is equation 1. Now as I have told, differentiating with respect to theta. Differentiating with respect to theta. So it gives n into r raised to n minus 1 dr by d theta is equal to, here a raised to n constant, differentiation of sin n theta is cos n theta. Then again applying chain rule, differentiation of n theta is n. So this n and this n get cancelled. So which gives dr by d theta is equal to, this is a raised to n cos n theta as it is, divided by this r raised to n minus 1, or which is equal to, this can be written as a raised to n cos n theta divided by, this can be written as r raised to n into r raised to minus 1. Correct? Or dr by d theta is equal to, here 1, this r raised to minus 1 means taking this in the numerator, so then it gives r raised to plus 1 and a raised to n cos n theta divided by r raised to n. Okay. Now again, from the relation, from this equation, what is r raised to n? From this one, r raised to n is equal to a raised to n sin n theta. Now substituting this value of r raised to n here, so which gives r a raised to n cos n theta divided by this r raised to n means a raised to n sin n theta. So again here a raised to n get cancelled. Correct? So now dr by d theta gives dr by d theta is equal to, it becomes r raised to this cos n theta by sin n theta is cot n theta. Okay? So now dividing throughout by r, dividing throughout by r, dividing by r, so it gives 1 by r dr by d theta is equal to cot n theta. Correct? Now reversing this, so reversing this it gives, which implies r into d theta by dr is equal to, this also be reversed, means this is now cot n theta divided by 1, it is the same as cot n theta divided by 1. So now reversing this, it gives 1 by cot n theta, or 1 by cot n theta is tan n theta. Okay? Or in other words, this is nothing but what? This is nothing but formula for the angle between the radius vector and the tangent, that is tan phi. Okay? Now since r into d theta by dr is nothing but the tan phi, which is for angle between the radius vector and the tangent. Okay, so using that, which gives tan phi is equal to, so in this, using r into d theta by dr as tan phi is equal to tan n theta. So both the sides tan get cancelled, so which gives phi is equal to n theta. Okay, phi is equal to n theta. Okay, after this is the angle between the radius vector and the tangent. Now we got this. Now by using the length of the perpendicular formula, so what is, we know that P is equal to r sin phi. So this is the length of the perpendicular, P is equal to r sin phi. Now substituting this phi in this equation, right? So now substituting phi is equal to n theta, which gives P is equal to r sin n theta. P is equal to r sin n theta. P is equal to r sin n theta. Okay. So now next is call this equation as 2. Call this equation as 2. So now from equation 1 and 2. So from 1, what we have? From 1 we have r raised to n is equal to a raised to n sin n theta. So this is from given problem. Okay. From 1 we have this one. Now from these two equations we should eliminate sin theta, sin n theta. We should eliminate sin n theta. So that is either you calculate sin n theta from this expression and substitute here, or you calculate sin n theta from this expression and substitute here. Either anyone you can do that. Okay, so now from 2 I will write sin n theta is P by r. Now substituting this in, this is equation 1, right? This is equation 1 in 1. So what I will get, so that is r raised to n is equal to, this is a raised to n as it is. Now sin n theta is P by r. Okay, or cross multiplying r raised to n into r is equal to a raised to n p. So now this is same as by using the laws of indices, r raised to n plus 1 is equal to a raised to n plus p. So this is known as the Padel equation. So this is the Padel equation. So Padel equation means what? It is an equation which is involving p and r, and it does not contain any trigonometric functions. Okay, Padel equation means what? It involves only p and r, and it does not involve any trigonometric functions, sin theta, cos theta, tan theta, like that. Okay, so this is the Padel equation. In the same way, we solve the second problem. Find the Padel equation. Find the Padel equations or Padel equation of the curve r is equal to a cos x square theta by 2. R is equal to a cos x square theta by 2. Now call this equation as 1. Now solution. Okay, so continue as you have done in the first problem. So what are the first? Differentiating 1 with respect to theta. Differentiating 1 with respect to theta. So what I get? dr by d theta is equal to this a is constant. Okay. Now differentiation of cos x square theta by 2. So first you differentiate cos x square. So 2 cosec theta by 2. Again differentiation of cosec theta by 2 is minus cosec theta by 2 and cot theta by 2. So here minus cosec theta by 2 means 1 cosec I will multiply this, and in the another one is cot theta by 2. Then differentiation of again theta by 2 is 1 by 2. Right? So this is dr by d theta. Now after getting this dr by d theta, then simplify this, which gives dr by d theta is equal to, so 1 by 2, this 2 and 2 get cancelled. Okay, so next it becomes minus a. Okay, now see here, this minus a cosec square theta by 2 is nothing but r. From 1, this is nothing but r. Correct? So here minus a cosec square theta by 2. So a cosec square theta by 2 is equal to what? R. So replace this here. So which gives minus r into this cot theta by 2 as it is. Cot theta by 2 as it is. So dr by d theta is equal to minus r cot theta by 2. Okay. So now after obtaining this, I again divide by r. So what I do? Dividing throughout by r. Okay, so here in this, here divide this whole equation by r, so that here r get cancelled and this is divided by r. Okay, so with this it gives 1 by r dr by d theta is equal to minus cot theta by 2. Now reversing this, r into d theta by dr, which implies next this is also to be reversed, so it becomes minus 1 divided by cot theta by 2. Okay, or this is same as minus tan theta by 2. Okay, now this is nothing but angle between the radius and the tangent, that is tan phi, which is equal to this minus tan theta by 2 it is same as tan of minus theta by 2. Okay, so both the sides tan will get cancelled, so phi gives minus theta by 2. Phi is equal to minus theta by 2 you will get. Okay, or otherwise you can write this as tan of pi minus theta by 2, because tan of pi minus theta by 2 is again, it is an even multiple of 90, so tan theta by 2, so pi minus means it comes in the second quadrant, so second quadrant tan is negative, so it is same as this one, so therefore this can be taken as phi is equal to tan get cancelled, pi minus theta by 2. Okay, so now we have by length of the perpendicular formula P is equal to R sin phi. Now substituting this phi here, so substituting phi you get P is equal to R sin phi means pi minus theta by 2, or P is equal to R sin of pi minus theta by 2, so sin remains sin only, because even multiple of 90 or odd even multiple of 90, so sin remains sin only. Then pi minus means it comes in the 0 to pi by 2, pi by 2 to pi minus means it comes in the 0 to pi by 2, pi by 2 to pi. Okay, then pi minus means it comes in second quadrant sign is positive, so sin theta by 2 you will get. P is equal to sin theta by 2. Okay, P is equal to sin theta by 2 you get. Then this implies P by R is equal to, dividing throughout by R, P by R is sin theta by 2. P by R is equal to sin theta by 2. Okay, so now what we have actually from the given equation, we have, this is the given equation, R is equal to A cosec square theta by 2, correct? So we have to convert this in terms of cosec theta by 2. So reversing this, which implies R by P is equal to, reversing this is 1 by sin theta by 2, which is equal to cosec theta by 2, correct? So now this is equation 2. Now substituting equation 2 in 1. Okay, so that is in equation 1 what we have, R is equal to A cosec square theta by 2. So what is cosec theta by 2 from this equation? It is R by P. So cosec square means it is whole square. Okay, and cross multiplying, which gives R into this is P square, which is R square, or 1 R and R get cancelled, P square is equal to AR. P square is equal to AR. So which is the required pedal equation for the given curve. This is the pedal equation, which is in terms of P and R, and it does not contain any trigonometric functions, sin theta, cos theta or tan theta. Okay, so with this I conclude this class, and in the next class we see some more problems on pedal equations. Thank you.